Welcome back to the course. This is Introduction to Azure Networking, and this is Lesson 6, where you'll deploy your second Azure Virtual Network. By way of introduction, just a quick recap that links to the prerequisites for the course can be found in the Introduction section, and links to the deployment scripts which are hosted on GitHub can be found in the Resources section. In this lesson, we'll learn how to reuse, update and remove resources from the deployments performed in the previous lessons, how to use the Azure CLI more effectively by combining it with simple PowerShell scripting, including iteration, conditionals, working with JSON and the query function, how to create a second resource group so that we can split our deployment across multiple containers for better organization, how to create a second virtual network with one subnet and a network security group to provide connectivity for the second virtual machine. We'll recreate the second virtual machine with the network interface attached to the subnet in the second virtual network. We'll create a peering relationship between the first and second virtual networks. We'll connect to the first virtual machine using Bastion in the first virtual network. We'll connect to the second virtual machine, also using Bastion via the virtual network peer. We'll verify connectivity between the first and second virtual machines. And finally, we'll recap on the effective routes and security rules of the network interfaces so we can observe how Azure manages the additional address space introduced by peering two virtual networks. Let's review the topology diagram for this lesson. First, let's recap on the resources that we're reusing from the previous lessons. These include the first resource group, the first virtual network and two of its subnets, the first virtual machine and its associated resources, and the Bastion and its public IP address. We now also have a second resource group, a second virtual network with one subnet, and we've recreated the second virtual machine attached to the second virtual network. And finally, we've paired the two virtual networks together. And now let's see what this looks like in the Azure portal once everything's been deployed. Here we are in the first resource group view, and we can see a list of the resources that we've deployed. From the top, we have the existing resources, which include the Bastion and its associated public IP address, the network security group for the first subnet, the first virtual machine, its operating system disk and its network interface, and the first virtual network. Next, we have the second resource group view, and again, from the top, we have the network security group for the first subnet, the second virtual machine, its operating system disk and its network interface, and finally the second virtual network. Now it's time for our demonstration, so let's get started. Here we are in Visual Studio Code. We have the deployment script open and our terminal is ready. As usual, before we execute the script, let's review it so we can understand what it's doing. From the top, we have our variables. In the first resource group, there are a number of resources which we're either going to reconfigure or delete. To do this, we need its name and location, along with the names of the virtual network, its first subnet and its network security group, and the first virtual machine and its network interface. Next, we're going to create our second resource group, so we need its name. We're then going to create the second virtual network, its subnet and its network security group, so we need their names and their address prefixes. We're going to recreate the second virtual machine, so we need its name, along with the names of its network interface and its operating system disk. And finally, we'll reuse the virtual machine size, the operating system image, and the username and password from the previous deployments. Now we have our variables defined, we can begin reconfiguring or deleting our existing resources, and in this script we'll start to introduce some additional methods for using the Azure CLI more effectively. Recall from our deployment in Lesson 2 that we created 4 security rules in the network security group. We now want to delete those rules, but without creating 4 individual delete commands. Instead, we can introduce iteration to remove unnecessary repetition from our script. Also in Lesson 2, we learned how to retrieve the private IP address of a virtual machine. To do this, we used a show command, applied a basic query filter, formatted the output, and stored the result in a variable. Let's now build upon that foundation. It will be helpful for us to retrieve a list of the security rules from the network security group. Fortunately, there is a list command that just requires the name and resource group of the network security group. We'll omit the query filter to capture the entire result. We'll format the output as a JSON string. We'll pipe that into the convert from JSON commandlet. And finally, we'll store the returned object in a variable. Now that our variable contains the list of security rules, we can iterate over this by using a loop. If this is the first time you've seen a construct like this, don't worry, we'll go through it step by step. To start the loop, we use the for-each keyword. Then, inside of parentheses, we specify two parameters separated by the in keyword. The first parameter is a temporary variable that the loop initializes for us at the beginning of each iteration, where it assigns the next item in the list. The second parameter is the collection to iterate over. In our case, the list of security rules, which we've just retrieved and stored in a variable. Then, inside of curly braces, we specify the commands to execute on each iteration. To delete the security rule, we need its name. We can access this via the temporary variable that the loop initializes for us using dot notation and the key we wish to retrieve. In this case, the name. We'll then assign this to another variable, which we'll use in the subsequent command. Next, to actually delete the security rule, in addition to its name, we also need the name of the network security group and its resource group. As you can hopefully see, this is a much more elegant solution as opposed to declaring 4 individual delete commands. Next, we'll disassociate the application security groups from the first virtual machine. This requires the name and resource group of the network interface, along with the name of its IP configuration and the parameter to remove the application security groups. We now want to delete the second and third virtual machines, their operating system disks, and their network interfaces. Again, we could achieve this with 6 individual delete commands, but we already know of a more elegant solution, so let's reuse this here. We'll first retrieve a list of the virtual machines, which just requires the name of the resource group. We'll again omit the query filter to capture the entire result. We'll format the output as a JSON string. We'll pipe that into the convert from JSON commandlet, and finally we'll store the returned object in a variable. Now that our variable contains the list of virtual machines, we'll again use a loop to iterate over the list. We'll start the loop with the for-each keyword. Inside parentheses, we'll specify the temporary variable that the loop will initialize for us, and the variable that contains our list of virtual machines. Don't forget to use the in keyword to separate these. Inside curly braces, we'll specify the commands to execute on each iteration. To delete the virtual machines and their associated resources, we need several values. We can reuse the dot notation again here, storing the results in variables. Each item in the list contains the name of the virtual machine and its operating system disk, so we can access these directly. We also need the name of the network interface. However, instead of being able to access this directly, the list item contains its fully qualified resource ID. First, we'll assign the resource ID to a variable, and then we'll use another function called split, also accessed using the dot notation, to obtain the field that contains the name. The split function accepts a parameter in parentheses. In this case, the delimiter we want the function to use, a / enclosed in double quotes. Since we only want to obtain the name, we need to filter the results of the split function, which we can do using square brackets along with the index number of the field that we're interested in. A fully qualified resource ID contains multiple segments, delimited using a /. The name of the network interface is in the final segment. Fortunately, we don't need to know how many segments the resource ID comprises of, because there's a shorthand way to access the last segment, using the index number of -1. We know that there are a total of 3 virtual machines in the list, but we only want to delete the second and third. We can determine which virtual machines to delete by introducing an additional scripting technique, conditionals. Again, don't worry if this is the first time you've seen a construct like this, we'll go through it step by step. To start the conditional, we'll use the if keyword. Inside parentheses, we'll then specify a condition which will evaluate to a Boolean value of true. In this case, we'll use the equality operator, -eq, to compare the name of the virtual machine in the current iteration with the name of the first virtual machine also stored in a variable. Inside curly braces, we'll specify the commands to execute when this condition evaluates to true. In our case, we want to preserve the first virtual machine, so we'll just output a message to the terminal which indicates this. Now we need to specify the commands to execute when this condition evaluates to the Boolean value of false. We do this by using the else keyword, and then again, in curly braces, we specify the commands to execute. In our case, we want to delete the virtual machine, which we can do by providing its name and resource group, along with the yes parameter. We also want to delete the network interface, which we can do by specifying its name and resource group. And finally, we want to delete the operating system disk, which we can do by specifying its name and resource group, along with the yes parameter. Hopefully you can now start to see the power of combining basic scripting techniques. Next, we want to delete the second subnet. We can do this by providing the name and resource group of the virtual network, along with the name of the second subnet. We can then delete the network security group, which we can do by providing its name and resource group. Next, we can delete the application security groups. Again, we know there are 4 of these to delete, and we now have the skills to be able to retrieve their details and then use iteration with a single delete command. So, we'll list the application security groups by providing their resource group, convert the output from JSON to an object, and store the object in a variable. We'll then iterate over the object, retrieve the name of the application security group and store it in a variable, and then we'll delete the application security group by providing its name and resource group. Now that we've either reconfigured or deleted the resources we're no longer using, we can start to add the new resources into our deployment. First, we'll create a second resource group to better organize our resources. For this, we just need to provide the name of the resource group and its location. Next, we can create the second virtual network. This requires its name and resource group, along with its location and address prefix. Notice here that we're using a query filter to obtain the resource ID of the new virtual network at the time of creation, which we're then storing in a variable. We'll use this resource ID later in the script to create the peering relationship to the first virtual network. Next, we can create the network security group for the subnet in the second virtual network. For this, we just need its name, resource group, and location. We can then create the subnet, for which we need the name and resource group of the virtual network, along with the name and address prefix of the subnet, and the name of the network security group. Now we can recreate the network interface ahead of recreating the second virtual machine. For this, we need the name, resource group, and location, along with the name of the second virtual network and its subnet. We can then recreate the second virtual machine, for which we need its name, resource group, and location, along with several other parameters, including its size, its username and password, its operating system image, the name of the operating system disk and its associated SKU, and the name of its network interface. Before we can configure the peering relationship between the virtual networks, we need to obtain the resource ID of the first virtual network, which is already deployed. We can do this using a show command, providing the name and resource group of the first virtual network, along with a query filter for the resource ID, which we can then store in a variable. We can then peer the first virtual network to the second. For this, we need the name and resource group of the first virtual network, the name of the peering relationship, the resource ID of the second virtual network, and the parameter to allow virtual network access. Finally, we can peer the second virtual network back to the first. For this, we need the name and resource group of the second virtual network, the name of the peering relationship, the resource ID of the first virtual network, and the parameter to allow virtual network access. We can now execute the script, which will deploy the resources. Here we are again in Visual Studio Code, this time with our terminal window maximized. Let's execute the script and observe the deployment. If you're following along, in a moment you may wish to pause the video here until the deployment is complete on your side. Now our deployment is complete, let's change over to the Azure portal to review our resources. Here we are in the Azure portal, back in the first resource group view. Let's review the virtual network. Under Settings, we'll review the peerings. Here we can see the peering to the second virtual network. If we review the peering, we can see that the first virtual network is allowed to access the second virtual network. Let's now change to the second resource group view. Again, let's review the virtual network. Under Peerings, we can see the peering to the first virtual network. Again, we can see the second virtual network is allowed to access the first virtual network. Now that we've reviewed our resource deployment, let's connect to the virtual machines via Bastion. Here we are back in the first resource group view. Let's go back into our first virtual machine and choose Connect via Bastion. We'll enter the username and password for the virtual machine. We'll then choose Connect. And in our new tab, we can see that we have an SSH connection to our first virtual machine. Next, let's validate connectivity to the second virtual machine. We'll try to perform a ping. Note that the IP address of the second virtual machine is now within the address space of the second virtual network. Here we can see that we've received a response to each of our requests. Next, let's return to the second resource group, and this time we'll try to connect to the second virtual machine. We'll again choose Connect via Bastion, and we'll enter the username and password. Then choose Connect. Here we can see that in another new tab we also have an SSH connection to our second virtual machine. Next, let's validate connectivity back to the first virtual machine. We'll again try to perform a ping. Here we can see that again we've received a response to each of our requests. Next, let's review the effective routes and effective security rules of the network interfaces. Here we are back in the first resource group view. Let's go into the network interface of the first virtual machine, and let's review the effective routes. Here we can see that, in addition to the 10.1/16 system route for the virtual network, we now also have a 10.2/16 system route with the next hop type of VNet peering. Next, let's go back to the second resource group view. Let's go into the network interface of the second virtual machine, and again we'll review the effective routes. Here we can see that, in addition to the 10.2/16 system route for the virtual network, we now also have a 10.1/16 system route with the next hop type of VNet peering. Next, let's go to Network Watcher to review the effective security rules. Here we are in Network Watcher. Let's review the effective security rules. We'll select the first resource group, and then the first virtual machine. We'll then select the network security group associated to the subnet. Here we can see the inbound and outbound rules, and we can observe that the virtual network tag now has 3 prefixes. If we select the virtual network tag, here we can see that it includes both the 10.1/16 and 10.2/16 address spaces. If we now select the second resource group, here we can see that the virtual machine, the network interface, and the associated network security group is automatically selected for us. Again, we can see the inbound and outbound rules, and again the virtual network tag has 3 prefixes. If we select the virtual network tag, we can again see that it includes both the 10.1/16 and 10.2/16 address spaces. That concludes this lesson. I hope to see you in the next one, where you'll deploy your first Azure mesh topology. See you next time.